Okay, so I first have a circle. Now, this is what I'm going to do. Within the circle, first of all, I'm not going to integrate the whole circle. I'm only going to focus on this part. Okay. Using that part of the circle, I can find the height, right? Because it's a very simple way to do that. It's just x squared. We know that circle has an equation of x squared plus y squared is equal to r squared, which means that's r, which means that point right there is 0r, and this point right here is r0. Okay, so the setup is important. You know, when you're given a question, how do you set it up in the coordinate system? That in itself is sometimes a challenge. So the idea is with using the height, okay, this height, if I rotate that height about the x-axis, I'm gonna get this disk. Okay, do you see what I mean by that? I got this disk right here, right, with a certain thickness. Okay, and I do that one, another one here. If I do that at every single possible point from 0 to r, do you see that if I add up all those disks, I'm gonna get half of a sphere. So we just have to times that by 2. Okay, so that's the idea. So what's the setup in terms of integration? So let's say the volume of this is gonna be 2 times double the volume that we're gonna get from 0, integrating from 0 on the x-axis all the way to r. Now, we need to generate a function for the disk, okay, in terms of x. The disk is pi r squared, right? Pi, I'm gonna say big R as a function of x. Okay, it's pi r squared. So what is r? The r, we're actually referring to this height, aren't we? Okay, so then from this equation, okay, I know that height is the y value. Okay, so I'm going to isolate the y. It's going to be r squared minus x squared. So y is equal to then square root of r squared minus x squared. This is the height at every single given x value. Okay, so we're going to vary that x from 0 to r. When you plug it into this formula, we're going to get the height. So this radius can be replaced with square root of r squared minus x squared. Can it? Can't it? Right? Okay, let's simplify that. So this is a complete setup. This will give us the volume. 0 to r pi. You get r squared minus x squared dx. Okay? So now that's very easy to integrate. It's 2 pi. I'm going to pull the pi out to the front. It's going to be r is a constant. It's the fixed radius. So it's going to be r squared x minus 1 over 3x cubed. And you need to plug in 0 and r in here by FTC2. Okay, Fundamental Theorem of Calculus 2. Okay, now you just plug in r and you get r cubed minus a third of r cubed. 0 will make everything disappear. That's 2 pi times by 2 over 3 r cubed, isn't it? What is that? 4 over 3 pi r cubed.